Hi, I'm Paul. We're going to do the course mastery challenge for Khan Academy geometry course. There's 30 questions. They're randomized, so we don't really know what we're going to get. That said, let's get started. Oblique circular cone has a radius of 5 meters and a height of 6 meters. Give what is the volume of the figure? Give an exact answer in terms of pi. All right, so the volume of a cone and the fact that it's oblique doesn't change this is 1/3 pi r squared times the height. 1/3, okay, pi r squared. R squared is 25 times the height is 25, 150 times a third is 50 times pi is 50 pi. Okay. Circle centered at 0, 0 has a radius of 2 times the square root of 3. Where does the point lie? All right, so we've got to do a distance formula. Well, okay, you know what? We can do this a little bit easier than that. Let's do square root of 3 squared, 9 plus 4, 3, 6, 0, 5. All right. What is 2 times the square root of 3? 3.46. So it's actually inside the circle. Oh, wait, whoa, 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 whoa. Okay, no. I'm sorry. 2 times the square root of 3. So no, it's outside the circle. The distance from 0, 0 to negative 3, 2. So no, it's outside the circle. Sorry. What just happened there? Outside. Yikes. Draw the reflection that reflects, oh, the line of reflection that reflects quadrilateral A, B, C, D onto A prime, B prime, C prime, D prime. Okay. Got to pick some good points here. I mean, so C looks pretty easy. It's going to be right there. That's the line of reflection for that. Let's look at B. B goes over 8 and up 4. So if instead it went over 4 and up 2, how does that look? 4, 2, and 4, 2, and 4. Yeah, that looks pretty good. Here's a rough outline of below are A, B, C, and D, E, F. We assume that A, B equals DE, measure of A equals D, measure of B equals E. All right? It's a rough outline of fact that they are congruent. Okay. We can map ABC on a sequence of rigid transformations so that A prime equals D, B prime equals, B prime and E are on the same ray from D. Oh, okay. Well, doesn't it give us the answer then? B prime and E are the same distance from D along the same ray. Yeah, it actually says that here, doesn't it? Okay, yeah, I think that we're just reading the answer right out of the description. All right. Alessandra wants to prove that if quadrilateral ABCD has one pair of congruent and parallel opposite sides, then it is a parallelogram. Has one pair of congruent and parallel opposite sides, then it's a parallelogram. I can prove this by establishing the congruence of a single pair of triangles. Okay. Which pair of triangles should you be referring to? And which criterion should you use for establishing congruence? Okay, so here's what we can do. We use the AC diagonal. AB is parallel to DC, that we are given that, so we can conclude that angle BAC and angle DCA are congruent. They're alternate interior angles. All right, so now we've got congruent triangles. ABC is congruent to ADC. Why is that? Because AB is congruent to D. Well, yeah, AB equals CD. That is given. AC is a common side for both triangles, and BAC is equal to DCA, alternate interior angle. So we have a side angle side congruence. All right. Now, as far how much further do we need to take this? Well, I guess that's it. We need ABC and ADC. ABC, ADC. Well, it's one of the first two. Okay, ABC, CDA. And it is side, angle, side. Is there another possible answer here? Okay, that's wrong. Okay. Circle with circumference 6 is an arc. Whoa, hold on a second. A circle with circumference 6 has an arc with a 340-degree central angle. What is the length of the arc? Okay. Well, it's not offering me a calculator here, so let me see if I can just pull one up. Scoot this over. The circumference is 6. And the angle is 340. So 340 of 360 is taken up by the arc. And so the answer, it doesn't say what to round it to, but I guess we could round it to like 5.67. Let's try that. What is the length? What is the length of the arc? Okay. I feel like I don't understand the question because usually it says what to round it to, but that's the only thing I can think of. Whoa, 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 whoa. Okay. Scoot that over. The length of the arc. 5.67. Oh my God. All right, so they wanted it expressed apparently as a fraction. 17 over 3. Okay, let's go back here and try this. What is 17 over 3? It's exactly what I had. Well, actually, let me scoot that over a little bit so we can see it. Okay, yeah, 17 over 3, but it's the same answer. It would be yeah, it would be nice to tell the test taker what format do you want the answer in, but okay. Anyway, yeah, let's move on. Let's move on to the next one. Write the equation of a line that is parallel to 6x plus 1 and passes through the point negative 7, 1. So we can do this with a point slope formula. Point slope formula is y minus, and this is a point on the line, so y minus 1 equals, so it's parallel, so it's going to have the same slope, which is 6 times x minus x1, which is negative 7, so it's plus 7. Yeah, let's go with that. All right, given the measure of an acute angle in a right triangle, we can tell the ratio of the lengths of the triangle side relative to the acute angle. Here are the approximate ratios for measures 55, 65, 75. Use the table to approximate A, B in the triangle below. All right. So we have 55, so we'll use the first column. We also have the opposite leg. 55, we have the opposite leg. And which one do we want? And we want the hypotenuse. All right. Yeah, let me pull the calculator up then. We have the opposite and we want the hypotenuse. All right, so 5 over whatever we're trying to get is about 0.82. So if we divided 5 by 0.82, 5 divided by 0.82, opposite hypotenuse, 55, we get that. Yeah, it's about 6.1. Okay. And plot the image of the quadrilateral ABCD under a reflection across line L. Okay. Well, I'll just do it like this. I can never figure out which point to start with, but let's do this. B, if you're going to reflect it across L, B is going to be B. And C is 1, 2, 3, 4 units away from that. So C is going to be here, right? 1, 2, 3, 4. All right. Now, we've got to reflect A. A is going to be 2 units below the line, which is here. D is going to be 1 unit above the line, which is here. Does that look right? A and A, B and B, C and C, D and D. It does look right to me. Okay. Oh, no. All right. Graph the circle, blah, blah, blah. I'm going to need to, in the interest of time, write the equations out and then, come back and look at them. Okay, so we put the common terms together. We have, we got to get this into a standard formula for a circle, standard equation for a circle. So we'll put the common terms together, x squared minus 14x plus y squared minus 12y equals, and then subtract 76 from both sides, equals negative 76. All right, complete the square for x and y. Completing the square means we'll take half of the x coordinate, in this case it's negative 14, and half of it is negative 7, square it and add it, 49. Same thing with y. Half of negative 12 is negative 6, squared is 36, equals, and then we've got to add the 49 and the 36 to the other side as well. All right, so now we can get it into a standard formula, and that would be x minus 7 squared plus y minus 6 squared equals 9. The center is going to be at 7, 6, and the radius is going to be the square root of the term on the right side of the equal, so the radius is going to be 3. So what does that give us? 7, 6, and 3. All right, I have to erase the drawing before I can move this, but we are going to have this at 7, 6, and a radius of 3. Is that right? 1, 2, 3. Yeah, that looks good. Which expressions are equivalent to tangent of G? All right, well, the tangent of G, tangent is opposite over adjacent. So what do we have here? Well, yeah, okay, but not opposite to H. It's opposite to G. So A is wrong. HI over GI. That is opposite over. Whoa. Tangent of G is opposite over adjacent. All right. So HI is opposite over GI, which is adjacent. Yes, that works. Oh, yeah. I gotta think about these a little bit. But no, sine isn't gonna work because sine has the hypotenuse. Yeah, so that's not going to work. 1 over the tangent of h. Well, tangent of h is opposite over adjacent. But if you flip it, yeah, it would be the tangent of g. So let's go with that also. This is the AC is tangent to the circle O at point C. What is the measure of OAC? All right. Well, I mean, if AC is tangent to the circle, then the angle at C is going to be a right angle. And we got 63. We need something with 90 minus 63, which is 27. 27. Write the equation of the circle, which is graphed below. All right. Okay. Yeah. Yeah, we can do that. So it is, what is the, is it -2, -2? That's where the center is, right? Okay, so we've got x minus -2 squared plus y minus -2 squared equals the radius squared. What is the radius? The radius is, you can't tell. What are these things? So each one of these is 1/4 of a unit. So this is 1, 2, 3. That is 0.75, right? Radius. All right, so let's square the radius. 0.75 times 0.75. 5625. All right. Get rid of that. 0.5625. Is that right? Show me the calculator again. 5625. Okay. Yeah, that looks right. Certain circle can be represented by, oh, not again. By the following equation. What is the center of the circle? Well, the x-coordinate is 0. How's that? All right, I'm gonna have to write it out again and then bring it back. Okay, we're back. X squared. So, combining the terms here, x squared plus y squared minus 2y equals, and then we'll add 99 to both sides, complete the square for the y terms, and we get y squared minus 2y plus 1 equals 99, and then we have to add the 1 on that side as well. And then we can simplify 2x squared plus y minus 1 squared equals 100. So the center of the circle is at 0. It's at 0, 1, and the radius is 10. So let's put that in. 0, 1, radius 10. Casey was able to map line segment UV onto line segment ST using a, UV, okay, onto ST. Okay, using a translation and a rotation, Casey concluded, I was able to map line segment UV onto line segment ST. Using a sequence of rigid transformations without a dilation. So the figures are congruent, but they are not similar. What error did Casey make in her conclusion? So the error is that congruent is actually more restrictive than similar. Congruent means that they have the same size and shape. Similar means same shape, not necessarily the same size. So anything that's congruent is similar. So we should say that they are congruent and similar. Oh, right. Below is a right triangle, MNO. MO equals A. ON equals B. MN equals C. And altitude OP is constructed so that MP equals X and PN equals Y. Below is the proof of the Pythagorean theorem that a squared plus b squared equals c squared. The proof is divided into, 3 parts, where the title of each part indicates its main purpose. First is proving that a squared equals c times x. Okay. All right. Part 1. OMN is congruent to PMO. OMN is congruent to PMO. Yeah, well, it's the same angle. So, yeah, reflexive property, same angle. MNO is similar to MOP criterion. Well, we just have 2 angles, right? MNO, and MOP. MNO, MOP. Yeah, we got 2 angles. So, angle. A over X equals, all right, so now we have similar triangles. So A over X, so that's the MOP. We got the hypotenuse, and then the shorter leg would be the same as the hypotenuse, which is C of the larger triangle, C over the shorter leg, which is A, over X is C over A. All right. Show the steps. B squared equals C over, B squared equals C times Y. Oh, I see. Oh, that's how we don't have to do these. Oh, okay. Well, yeah, just go ahead and check it then. Okay, quadrilateral A prime, B prime, C prime, D prime is the image of quadrilateral ABCD under a translation. Determine the translation, use non-negative numbers. All right. So the teal one is being transformed into the, I'm not sure what color that is, purple one. So first of all, we are going 1, is that right? 1 unit to the left. 1 unit to the left. And how many units down? 1, 2, 3. 3 units down. 3 units down. Okay. Angle C is inscribed in circle O. Angle C is inscribed in circle O. All right. AB is a diameter of circle O. What is the radius of circle O? I'm a little bit surprised that we don't get a calculator here, but okay. So this C here is a right angle. It's a 90-degree angle. So we can use a Pythagorean theorem on this, and we've got 8 squared is 64, 15 squared is 225. Add them together, we get 289. What is the square root of 289? It's 17, right? So then the radius is 8.5. 8.5 units. Find the value of x in the triangle shown below. Okay, so one way to do it is to note that we have an equilateral triangle here. And so the 55-degree angle and this unlabeled angle up here at the top have to be the same, 55. So we need everything to add up to 180. So we got 55 plus 55 is 110, and the x is going to have to be 70. What is the surface area of a cylinder with base, radius 2, and height 5? Okay, the surface area. So we've got 2 circles, and then we've got the outer wraparound surface. Okay. All right. So the surface area of the top is pi r squared. Pi r squared, but then we have the bottom also. So it's so the top and the bottom together is 2 pi r squared, right? 2 pi r squared is and the radius is 2. So that's 4, 8. So that is 8 pi. Come on. Oh. Equals. Sometimes this just doesn't want to work. Equals 8 pi. All right. Now, to get the surface area of the outside of the cylinder, we need the circumference of the circle, which is 2 pi r times the height. 2 pi r 2 pi r times the height. All right, the radius is 2, the height is 5, so this taken together is 10. So that is 20 pi. Okay. All right, so I'm going to go with 28 pi on this. 28 pi. Okay. Chaim tried to prove that JKL is congruent to LMN. All right. Well, JK equals LM equals 3. Yeah, that's right. What's the first error? JL equals LN equals 5. Yes, that's given. KLJ equals MNL is 27. Given. All right. And then we have side-side angle congruence. All right. Used an invalid reason to justify the congruence of a pair of sides or angles. No, those were all given. Only established some of the necessary conditions. These, I hate these. It's just puzzling, what they actually mean. Established all. The thing is, side. What we want to say is that side angle is not a reliable proof method. You can do side angle side, but the angle has to be in between. I mean, the angle has to be in between the sides, not where it is there. He only established some of the necessary conditions. Well, I mean, yeah, but established all necessary conditions, but then he used, really the most on-point answer is that this criterion does not guarantee congruence. So let's go with that. Yeah. Okay. What is the central, what? Okay, a sector with area 48 pi square centimeters has a radius of 16 centimeters. What is the central angle measure of the sector in radians? All right, so we do get a calculator. That's good. So the area of the whole circle is pi r squared, which is 256 pi. We square the radius. And then to get the what are we trying to get? Oh, central angle measure in radians. All right. So that is, first of all, we got to get what fraction of the circle does the 48 pi represent? And so we can get that with, am I going to get a reasonable number here? 48 divided by 256, 0.1875, and the whole circle is 2 pi radians. What are the possible answers here? Okay, I don't think this is what I want. Let's just go back to this and say 48 over 256 times 2 pi. That is going to give us 96 over 256. Is that, what is that? That's 3/8. 3 pi over 8. Okay. So let's go with D. What happened? Why did it wipe out my answer? Okay. What single transformation was applied to quadrilateral A to get quadrilateral B? Well, I don't think you can reflect it over anything. It looks like a rotation to me. Heidi tried to use Cavalieri's principle to show that okay, that the two figures have the same volume. The base areas are the same. Therefore, corresponding cross sections must have the same area. I don't think the corresponding cross sections are going to have the same area. Both figures have a length, okay, to right. Okay. Yeah, the cross sections are not going to be the same. Cross sections are not going to be the same. Rectangle A, B, C, D is rotated 95 degrees about point Q to create rectangle A prime, B prime, C prime, D prime. What is the area of A prime, blah, 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 blah. Okay, so the area, I mean, if you rotate it, the measurements are going to be the same, so it's just 6 times 2, length and width, so that is 12. Oh boy. Okay. Following rectangular pyramid has a height of 2 units and a volume of 18 cubic units. The oblique rectangular prism is a congruent base and the same height, and the slant height is 3 units. What is the volume of the prism? Okay. All right, so we got to kind of back into like what is the area of the base. It doesn't tell us what the area of the base of the pyramid is, but the formula for the volume of a rectangular pyramid is length times width times height divided by 3. So it says the volume is 18 cubic units, so length times width times height has got to be 54, which we then divide by 3. All right, so length times width times height is 2, so length times width is 27, and we've got the base with an area of 27. All right, then we go over to the oblique rectangular prism. The slant height doesn't matter. It's the height that matters. So if we know that the base is 27, the height is 2, then it's going to be 27 times 2, which is 54. There it is, 54 cubic units. Consider the triangles shown below. Are the two triangles congruent? Didn't we do this once before? We have a side angle. That doesn't work. Okay. Angles A and C are congruent. In ABC, the figure is not to scale. Which of the following additional statements would allow us to prove that ABC is equilateral? AB is congruent to BC. No. AB is congruent to AC. Yes. We already know AB is congruent to BC. We need both. No, we don't need both. If we knew that AB is congruent to BC, that would do it. What is the scale factor of the dilation? Well, so we're going from this one to this one, and I don't know, let's pick something here. Let's pick like B, or I'm sorry, BA, which is 3 in the original, and then it's 2 in the dilation. So the scale factor is 2/3. All right. Last question. Point A is at -6, -5. Point C is at 4, 0. Find the coordinates of point B on AC such that the ratio of AB to BC is 2 to 3. All right. Think about that. Okay, so we got the calculator here. So we're trying to find the coordinates of a point that divides a line segment into a given ratio, and we can use the section formula. The section formula is, let's see, we got to do it twice. We got to do it for the x coordinate, we got to do it for the y coordinate. So x equals m times x2. M, the ratio here, 2 to 3, is, this is m. M is 2, n is 3. And this is -6, x1, -5 is y1, 4 is x2, 0 is y2. So we have, I think I'm going to need to put this in parentheses here, m times x2. So that's 2 times 4, 8, plus n times x1. N is 3, x1. All right, so it's actually not a plus. It's a -18. That whole thing goes over m plus n, just 5. Oh, okay, that was easy. -2. Okay. Now for For y, actually very similar, m times y2, which is 2 times 0, okay, plus n times y1, n is 3, y1 is negative 5, so we have negative 15 divided by m plus n, which is 5. Negative 3. All right. And that should do it. Okay. All right, that's it for geometry. Hope you enjoyed it. Please feel free to like, subscribe, comment, and see you next time.